Okay, so we have a AC sinusoidal current flowing through a resistor. We were told that the RMS value is I, which means the peak current will be root 2I. Alright, because I is the RMS value. So the peak value is larger by a factor of root 2. So if this is the current variation, then to get the power variation, we just have to think in terms of I square R. So we got to square this graph, huh? So obviously when the current is 0, think of I square R, huh? It should be 0 here as well. Here current is 0 again, so you get a 0 point here again. So this at T, and this is where T over 2 is, and they are all zeros, here, here, and here. So here we're going to have a peak current. Here where the current is negative maximum, you are going to have another peak power. And likewise here, huh? Here there's another peak. So the wave, the power variation is going to look like this. This point here will be another max. Alright. What is the peak power? Think of I square R again. So after squaring this thing, you are going to get 2I squared. Multiply with the R, so the peak should be 2I square R. Which makes sense, huh? Because I square R, if I is the RMS value, then I square R is only the average power. The peak power should be 2 times the average. So 2I square R. Another thing to note is the shape of this wave should correspond to a shape of a sine square graph, because the shape of this thing should follow this function, cosine square omega t. Alright, in fact it's just 2I square R times a cosine square omega t. And from mathematics we know that the shape of this graph is a smooth sinusoidal. So you have to reject the option that shows instead of a smooth sinusoidal, it shows something that is very lumpy, like this. This is not correct, simply because from mathematics we know that the shape should be a smooth sinusoidal instead of a humpy one. Alright, ta-ta!